Hello and welcome to the second new video for 2020 Lockdown Fall Semester Edition for AP Chemistry at USN. Should be a word you haven't heard maybe in a while unless you did the summer reading, hint hint, and that is stoichiometry. Just want to do a pretty quick video demonstrating some of the just simple manipulations of numbers that the mole and stoichiometry in general allows us to do. Things that you probably knew how to do in Chem 2, but maybe not with particular ease. And they need to be something that hopefully you can establish some comfort level with here in the next couple of weeks as we wrap up a quick review of the summer and last semester material, but also that you can kind of have as tools in a toolkit that allows you to solve all sorts of different problems. Things like this are going to pop up periodically throughout the year, so it's good to be able to do them. And that is just what I would refer to simply as simple stoichiometry. And we're just really going to delve into how to just do some quick manipulations. We'll just look at maybe two today, both revolving around just how to extract stuff out of a substance as opposed to maybe just using the whole substance by itself. So if I have something like 8 grams of calcium chloride, and the molar mass of calcium chloride 110.98 grams per mole. You're welcome. Last year you might have had to convert that to moles by dividing by the molar mass, or maybe that you needed to be able to figure out how many molecules were in there. Technically they're not molecules, they're formula units, but functionally the same thing. But in AP, while you might need to do that, that's certainly something that comes up. There might be other things that you would need to handle, such as how many grams of just calcium are there in calcium chloride. And probably last year you could do that. Maybe a lot of you would think about going the percent composition route, which you certainly can. Some of you might go the route where you would convert the whole thing to moles, and maybe we'll talk about each one of those in turn afterwards. But there's a much simpler way to approach this, and that is simply that 8 grams of calcium chloride. We're going to go back to our friend the factor label. And the factor label, the equivalence that's going to be in play here is really the same one you would use for percent composition. We just don't need to stop at percentages along the way. And that equivalence is simply that there are 40.08 grams of calcium, that's its molar mass, in every 110.98 grams of calcium chloride. That's its molar mass, as stated above. So that's an equivalence. I know that 40 grams doesn't equal 111 grams at all, but every time I have 110.98 grams of calcium chloride, I have 40.08 grams of calcium. I mean, they are equivalent in terms of the scope of this problem. So that would mean that the calcium chloride divides out, and I very quickly in one step converted 2 grams of calcium. And if we do that math, that equals about 2.88 grams of calcium. So again, that's a really easy one-step way to do that. There are some other ways. Again, you could convert to moles of calcium chloride in general by dividing by the molar mass, and then go to moles of calcium from there, and then go to grams of calcium. That would be multiple steps as opposed to one. It certainly is effective, though. There's no harm in that. You could also do percent composition. And if you do the percent composition of calcium, that essentially is what we did in the problem that we looked at a little bit more in detail, but you're sort of doing that separately, whereas the way I did it simply does it along the way and saves a little bit of time. But that may take some time in terms of feeling comfortable enough and kind of seeing through to problems like that, and that just takes practice, I think. So not every problem is going to be exactly the same, and that's sort of the point of a problem, is that it presents something a little bit different, a little bit unique, and that's going to cause you to have to look at that toolkit that you have and see how to make things work, and we're all going to do that a little differently. All right, on to a second problem. Again, back to our 8 grams of calcium chloride. Let's say that I simply want to know how many atoms of chlorine there are in that sample. So again, lots of ways to do this. We're going to have to get to the mole at some point and then use Avogadro's number to get out of the mole and to atoms. So we're going to convert 8 grams of calcium chloride to moles first. 1 mole, again, you were given 110.98 grams of that, so 110.98 grams per mole. That will give us moles of calcium chloride. And we really don't need to stop the problem. If we feel comfortable, we certainly can keep going. If you don't, feel free to solve that and then proceed from there. But the key is if I have moles of calcium chloride, the trick is how many chlorines are there for every one calcium chloride. And there are 2 Cl's in every one CaCl2. So our next conversion, again, 2 does not equal 1, and that's very important to sort of recognize that 2 does not equal 1, but 2 chlorines are the equivalent of 1 calcium chloride because they do represent the same thing. There are 2 chlorines for every 1 calcium chloride. So the calcium chlorides will divide out, and that'll give us moles of chlorine. Again, that's not what the question's asking, but we are one step closer. So once we have moles of chlorine, we use Avogadro's number. It may have been a while, depending on when you did the summer work, since you've done this, but there are certainly 6.02 times 10 to the 23rd atoms per mole. And so the moles will divide out. And now we have the units that are left, atoms and chlorine at this point. Please note that I did write my units with Avogadro's number. That tends to be something that students get a little sloppy with. The other thing they get sloppy with, again, is just writing this as 2 over 1. 2 over 1 is not an equivalence and is just not acceptable. That does not sort of present itself as a form of an equivalence or a form of the number 1. They are not the same thing, but 2 Cl's per 1 CaCl2, that does qualify. If we do this math, around 8.68 times 10 to the 22nd atoms of chlorine. And again, from a number sense perspective, that should make sense. 8 grams is a far cry from a mole's worth of calcium chloride. It's less than 10%. So we would expect, given that it's less than 10%, that the power of 10 would drop by 1. So instead of 10 to the 23rd, 10 to the 22nd would be a reasonable sized answer. So it's good to develop that skill as you go through the year as well, to kind of ask yourself, does that answer make sense? Is it plausible? Does it live in the reality in which we inhabit? Okay, pretty quick video today. Hope that it makes sense, and we'll be back at it again the next time. Thanks.